know the substitution method. So this is just what we did yesterday. And I'm not going to lie. I'll be completely honest with you. I don't like doing this. And it's my least favorite thing to teach just because there's so many steps and there's so many different places where you can mess up. And when you guys were doing it yesterday, you saw that something as simple as a sign error affects everything. So what I'm going to do today is I'm going to show you the second strategy. The second strategy is called substitution. It's actually the one that I prefer. So like when you guys get your test, if it just says solve it, you can solve it however you want. The only reason I showed you this stuff that's on the board right now is because there's always a question on the test where someone solves the problem wrong and you have to find where they messed up. So I don't know how that person is going to solve it. If they solve it using the substitution method, then I got you covered. Because that's the only reason why I showed it to you yesterday. From now on, if it doesn't tell me how to do it, I'm always going to do it using this new method. So if you guys will flip over in your notes to this page, this new method is called elimination. Now, I was playing around on the internet. Some people call it elimination, but a lot of textbooks, and there are some web pages also, they refer to it as a linear combination. So I want to start with that word first. What does it mean to combine something? Put it together, right? If I was going to combine classes with Miss Prather, we would put our classes together, probably in the same room. That's what combining means. So that's basically what we're going to do with our two equations of our system. Now, it's also referred to as elimination, and that's how I usually say it because linear combination is too many syllables. So I just refer to it as elimination. But here's the reason why it's called that. So first, it's called linear combination because we are going to combine these two equations, which happen to be linear. Now, this is going to hopefully bring up some memories from way back in the day. You guys remember without calculators when you had to add 472 plus 384? You know how you had to line up the ones and line up the tens and then line up the hundreds and do the columns? That's exactly what we're going to do here. So the first thing to note is take a look at how all of the x's are right here. And all of the y's are right here. And all the equal signs are right here. And then all the numbers are right here. So this one, it's set up for the elimination method. Now let me also tell you this though. If you guys recall yesterday, you guys remember yesterday we started off with a freshman level question and then we bumped it up to Algebra 2? That's what I'm about to show you right now. The only difference between Algebra 1 and Algebra 2 is in Algebra 1, their questions are ready to go right away. In Algebra 2, we gotta manipulate it just a little bit before we can get started. So in this question right here, this is an example of a freshman level question. And I know that because in the elimination method, if I was to combine the like terms by the columns, what happens to 2x minus 2x? They go away. That's why this is called elimination. The elimination method causes letters to disappear in the very first step. So then we combine what's left. 3y plus 1y is 4y. 20 plus 4, 24. Now we can solve for y. If I just divide both sides by 4, I get y equals 6. Now, I want to flash back to what we did yesterday. Look at this. Look at how many steps it took before we got to the first answer. So I think it's safe to say the new way of doing it is faster, right? Okay, but we still need a second answer because solutions are the points where they cross, and points are made up of x's and y's. If I know that y is equal to 6, how do you think I'm going to figure out what the x is? Just plug it in. Now, here's the other thing too. I've got two different equations. Does it matter where I plug it in? Not really, because they're both going to cross at the same place anyways. Now, I do have my own way of doing things. Like, I prefer not to work with negatives because I know students mess up when there's negatives. And when I can, I'll work with the numbers that are smaller. Honestly, it doesn't matter, but usually that's what I go for. So I see in the top one, they're all positive. I see in the bottom one, there's a negative there, but all the numbers are smaller. So I'm actually going to just do the bottom one. So in the bottom one, I'm going to take negative 2x plus y equals 4. And then I'm just going to plug in the 6. And then I'm going to solve for the x. So this ends up being negative 2x plus 6 equals 4. So I minus 6 from both sides. So that's negative 2. I have the negative 2x here. And I just divide by negative 2. So x equals 1. So again, when we write our answers to be systems, we put them in parentheses because they are really just where they're crossing. If we were to graph it, they're going to cross at 1, 6. Now, I had a girl in the last class that just left. She put 6 and then 1. Don't fall for that, guys. Don't do all this work. Do it all right, and then put it into the final answer wrong. Always remember to put the x here and the y here. So it's not, you don't put it in based on what you got first. You look at the actual letters, and then you put them in their spots accordingly. Now, just with that preview, what do you guys think so far? Do you think that's something you maybe can do? Do you like that one better than substitution? Because I do. I like it so much, like especially this problem because it was so short. It might be the next tattoo I get on my lower back. Just kidding, I don't have tattoos. I'm afraid of needles. Okay, here's what I want you to do. I know this is quick, but I'm actually going to pause for a couple seconds to see if you can do it. So the you try it question, I want you guys to try it. Remember, this is the freshman level right now. So I'm going to give you about 2 minutes to see if you can solve it the same way we did the other one. So as I walk around and check on people, so earlier you guys said that this one is shorter, and some of you like it better than the other one. But what I'm finding is there are still those tiny mistakes that we need to clean up. For example, people are adding wrong. There are people who are ignoring signs. Those little mistakes cost you big time on our tests. One tiny sign mistake or adding something wrong messes up everything, and it just snowballs, and it gets worse the more you do. So you have to be extremely careful. Now, I'm also going to ask you this question, though. When you look at these problems, are you able to tell which letter is going to cross out? How can you tell what letter is going to cross out without actually doing the work? Are there certain features that the letters have that make them cross out? Yeah. Perfect. So that's one thing. One has to be a negative and one has to be a positive. But they also have to be the same number, right? We call those opposites. They have to be opposites. If one's plus 10, the other one has to be minus 10. In this one, we have a plus 4 and a minus 4. So those are the ones that are going to cross out. So these cross out. We're going to add this stuff together. 16x equals 32. Remember, we got to clean up those small mistakes. Well, hold on a second. In the other class, I had someone tell me the answer to this is 16. How do you think they got 16? Yeah, they didn't divide, but what did they do? Well, I think they probably did 32 take away 16, maybe, right? The overall answer to this should be 2, though. Okay, so now, how do you find the second answer? Just plug it in. And so it doesn't really matter which problem you plug it into. Me personally, I have a preference. I like all positives and small numbers. So if it was me, which one do you think I would choose? I would choose the top one. It's not going to matter. If you do the bottom one, we're going to get the same answer anyways. So in the top one, I'm going to use 7 parentheses plus 4y equals 2. We found that the first answer was 2, so we plug it in. That's now 14 plus 4y equals 2. So I'm going to subtract 14. Subtract 14. So I have 4y equals negative 12. And we divide both sides by 4. We end up with negative 3. So guys, also don't forget, on the test, we want to see it written as an ordered pair. So put the x first and the y second. So 2 goes here, negative 3 goes here. So I want to come to a consensus. I hope you guys all agree this is much shorter than what I showed you yesterday, right? Okay. Hold that thought though. because we have another problem down here, but we're going to experience some issues. So take a look at this next question. 3x minus 4y equals negative 5, and 5x minus 2y equals negative 6. What's the issue? Yeah, there's no opposite. That means nothing's going to cancel. So remember the corny card joke I made earlier about manipulation? I'm going to teach you guys how to manipulate your problems without actually changing the problem. It's pretty dope. Now, on your paper, this stuff I'm about to show you is not on your paper, so just stop looking at your paper and look up here. So here's my question to you guys. Are these two problems the same? Really? Wow. Well, for those of you that can't see it, I'm going to prove it to you. If I get them to say y equals, that's how we can really see if they're exactly the same. So I'm going to make this a 1. I'm going to subtract 1x, subtract 1x. So this is negative 1x plus 3. This is 2y. Divide 2, divide 2, and divide 2. So I end up with y equals negative 1/2 x plus 3 over 2. That's the first one. If I look at the second one and I do the same math, like all the numbers are different, but at a certain point, you will notice that something kind of special happens. If I divide all of these by 4 and then simplify it, negative 2 over 4 is negative 1/2 x. 6 over 4 reduces to 3 over 2. So even though the two problems had different numbers in them, when we solve them for y, you can clearly see that they're the same exact line. Now, some of you I heard you mention why this is happening. If you can't understand why this is happening, all you got to do is sort of like compare the x to the x, the y to the y, and the number to the number. If you make that comparison, there is a pattern that's happening here. What was the pattern? Good. This one goes from a 1 to a 2. That one goes from a 2 to a 4, and that one goes from a 3 to a 6. They're basically multiplying by 2. So when we experience problems that don't cross out the way that we want them to, we can actually manipulate them through multiplication. If I take this entire problem and I just multiply it by 2, it becomes this, which in turn is still the same exact thing, even though it looks different. And the proof of that was on the last page. So that's how we're going to attack some of these problems. Now, before we get into that, though, I wrote a problem over here on this board, and I want to review something from yesterday. Yesterday, when we did elimination, I had you guys go after a certain letter. It was my favorite letter in the problem. In this problem, what's my favorite letter that I want to solve for? And why is it the x? Okay, so when we solve, if your x has a 1 on it, that means you're going to divide by 1, therefore you should not have any fractions. That's what makes it my favorite. The same thing is true in this stuff. If I want to make these numbers match, but also be opposite, the one I'm going to make go away is the one that has the 1 on it. So in this example here, I'm going to choose to make these x's cancel. The way I'm going to do that is through multiplication. So if I need this, the 1x, to become a 3x, what would I have to multiply it by? I would have to multiply it by 3. But if they were both 3x's, would they cancel? Positive 3x and positive 3x cancels? So that's the last thing that we have to decide, whether or not we need the signs to change. They can't both be positive and cancel, so instead of multiplying by a regular 3, we would multiply by a negative 3. So my favorite letter, it doesn't change. My favorite is the one that has the 1 on it. So let's go back to our problem. What's my favorite letter? No. So that strategy doesn't work here, right? So I'm going to give you another strategy. Let's just take it letter by letter. Let's just start with the x's. I got a 3 and I got a 5. Let's start with the small one. Could you turn the small one into the bigger one by multiplication? Can you turn a 3 into a 5 using multiplication? So let's go to the y's. I got a 4 and I got a 2. Can you turn the smaller one into the bigger one? Yeah. What would we have to multiply by? Okay? Okay, there it is. That's what I'm looking for. not only do we have to take that problem and multiply it by 2, we're actually going to have to multiply it by -2, so that way the top one has a -4 and the bottom one has a +4. That way they can cancel. I'm gonna tell you guys a big warning right here. The biggest mistake people make, they multiply this and they multiply this, and then they completely forget about the -6. The only way for this problem to be the same is for you to multiply all the way through. So this problem is going to look a little different. Oh, I forgot, it's a -2, right? So this problem is going to say -10x plus 4y equals 12. And then the top one, we don't need to mess with it. We can just leave it. So 3x minus 4y equals -5. Now will stuff cancel? See, and that's the thing that's amazing about this stuff. You guys are becoming math gods because you're controlling the destiny of this problem. And that's a pretty powerful thing. You should, when you walk around and see other people, you should feel like you're better than them. I'm just kidding. But it is kind of cool that you can manipulate these problems in a way that doesn't actually changes it, it just changes how it looks. So that way things work out the way we need them to. So these cross out. This leaves me with -7x, and this is a +7. And then we divide both sides by -7. So our first answer is -1. So again, how do we find the second answer? We just plug it in. Now I have some options though. Let me tell you this about plugging it in. Don't go plug it into the new problems that you made, because the new ones, they're the same as the old ones, they just have bigger numbers. So always go back to the original. You'll get the same answer, but I'd rather work with smaller numbers. Now in that problem right there, it looks kind of like a tie. There's 2 negatives in both of them, and most of the numbers are pretty close to each other. So I really don't have a preference. I'll just use the top one. So the top one says 3 parentheses minus 4y equals -5. We're going to plug in -1, which makes this -3 minus 4y equals -5. Try to get y by itself, so I have to add 3 first. So -2. I'm going to emphasize this right here. I got a lot of people in all my classes forgetting to drop down this negative. When you bring the 4 down, the negative comes with it. So now we have to divide by -4. So y equals, was it 1/2 or is it 2? Yeah, it's 1/2. If you're not sure, type it in the calculator, but the way you can tell is just by seeing where the bigger number is. Bigger numbers on bottom means it's going to be a fraction. And guys, there's nothing wrong with getting fractions. In fact, if we graph this, we're not going to be able to really tell what that fraction is unless our graphs are immaculate. Like, they have to be perfect. So that's why we have to know how to do this stuff by hand. That's the only way we can get a very accurate representation of where they're crossing. So this is -1 and +1/2. Okay, let's flip the page over. Let's talk about that strategy one more time. So take a look at the you try it right here. We're going to still do it together, but I want to talk about the strategy. Which letter should we make go away? The x or the y? And why is the x the better option? Yeah, that's the only one out of the 2 options that you can turn the small one into the big one through multiplication, right? If I try to turn 5 into 7, you can't. 5 times 2 is 10. You've already passed 7. So here's what we do. We need to multiply this to get it to turn into the 6. So what are we going to multiply it by? Now I want to ask you this though. Would it be +3 or -3? So remember, to cancel, our ultimate goal is to make one positive and one negative. They already have that feature. So we don't have to change any signs here. That's why we multiply it by a regular 3. So we're going to make this new problem. 6x plus 15y equals 15. And then the next one, -6x plus 7y equals -37. Now we're ready for the combination step. Linear combination. So we add them both together. My x's are going to cancel because we made that happen. So what's that, like 22y? Negative 22. And then we just divide by 22. So the first answer is negative 1. So to find the second answer, we got to go back and plug it in. Now you guys are starting to know me. Which one do you think I would plug it into? The first one or the second one? Now I'll probably do the first one because it doesn't have any negatives and it's got smaller numbers. Could you plug it into the second? Absolutely, you'll get the same exact answer. So I got 2x plus 5 times the answer we just got. I'll go back and put the negative 1 in. So I have 2x. Let's see, So I got 2x minus 5 equals 5. So I add 5 to both sides. 2x equals 10. And I just divide by 2. So x equals 5. So our ultimate answer here, 5 comma negative 1. So I just want to get like a feeling for how you guys are feeling about this topic right here. So let's do like an informal sort of vote. 1 to 5. The scale is 1 to 5. 1 is you're completely lost. 5 is, I got this. Give me the work so I can get it finished. Number 3 is, show me with your hands where you feel you're at with this stuff. Okay? That's good. It looks like a majority. A majority is 3s and up. Except for you just walked in, that's why you're at a 1. So I'm glad you guys are feeling a little bit confident with this. This is all going to be on nature, guys. Yeah.
What were we doing when you turned it into 67 plus 55?
What was I doing?
Yeah.
Oh, I erased it because you had already come in. But I showed them earlier you can multiply an entire problem and it's still the same exact line. So what I did was I just multiplied by 3. So we're forcing those x's to kind of be opposite so that they'll cancel.
Oh, you combine?
Yeah, it's called linear combination / elimination because when you do it, it causes things to go.
Oh, so the 6's cancel each other out. So you just like that.
I love your enthusiasm. Yeah. Go ahead. Okay, so most of you feel confident, which is good, but I don't think you're ready yet. So let's talk about that strategy one more time. So watch this. Which letter should we make go away? The x or the y? Wait, what was the strategy again? How did we decide which letter to pick? We got to take the small one and multiply it to turn into the big one, right? And so you guys are telling me x? You can't turn a 2 into a 5, though. You know what I like about you? You know your math. You know what I don't like? You steal my thunder. That is exactly 100% correct. The issue that we're going to experience is it doesn't matter if you pick the x or the y. You can't turn the small one into the big one. They don't go into each other. 2 does not go into 5. 8 does not go into 9. So the next option, and this is your last option, is to pull a move I call the switcheroo. Now don't Google that, because I don't know if that's really what it's called. I don't know what's going to come up when you Google switcheroo, so don't Google that. But the switcheroo is when you basically take the front number from each one and you switch them. So I take the 2 from the x and I put it here. I take the 5 from the other x and I put it here. Well, here's my other question. Do I need to make one of them negative?
No.
How can you tell if you do or you don't? Yeah, if you look at the signs of the original, this one's already a plus and this one's already a minus. In order to get them to cancel, they have to be plus and minus. So we don't have to mess with the signs. We just have to pull the switcheroo move and multiply. Okay, so that's going to actually change both problems. 10x minus 45y equals 40. And the other one is negative 10x plus 16y equals, what is it? Negative 40. Okay. Well, that's good. So this crosses out. What does that give me? Positive or negative? Negative 29y. And then those cross out, but I have to have something on the right side, so I'm going to put a 0. And then I'm just going to divide by negative 29, which doesn't matter. It's still going to give me 0. And remember, guys, I don't like working in the new problems when I go back to plug it in because they're the same as the old ones. They're just bigger. So go back to one of the old ones. Just out of curiosity, which one do you think I would use? I'll probably use the top one just because they have smaller numbers. The bottom one has 2 negatives also, so I try to stay away from that. So 2x, oh, I love plugging in 0. I love plugging in 0 because it just basically goes away. So this is 2x equals 8, and then we have to divide by 2 on both sides. So x equals 4. So the answer is 4, 0. So a big thing to this, you guys, was the strategy. That's what I'm more concerned with. The problems, they could look like anything. If they have a 1, that's the one you're going to mess with. You're going to multiply that to turn it into the other one, and just make sure it's the opposite sign. If the number doesn't have a 1, then you try to make the small one into the big one, and if you can't, then you just pull the old switcheroo move. And with those 3 strategies, you should be able to solve any question. Now remember, guys, I don't like this stuff, right? This had a lot of steps to it. Even with the manipulation we had to do on these questions, I still think it's a lot better than having to do the other substitution one. The only reason I taught that was in case on the test, the person did it that way, you'll be able to analyze the steps and try to figure out where they went wrong. So you guys have about 15 minutes to practice. I made you a new worksheet because I didn't like the other one. This one has 10 questions. 2 of them are the freshman level. So for the first 2, you don't have to multiply anything. You just make them cancel. And for the big math ideas, there's 2 questions. That's it. Oh, I forgot to mention this. You guys still have your notes out? Write this down. You will, don't write this part, hold on. You will see problems that have exponents. I didn't show you any that had exponents. But if you see a problem that has an exponent, make the y's go away. Every time. I promise you it's going to make your life a lot easier. If you see an exponent in your problem, you can still do this elimination method, but I need you to always make the y go away. Because we don't typically put the exponent on the y, so that's why we want that one to go away. And if you have an exponent, when you solve, that means you probably have to factor. And if you have to factor, that means you probably have 2 answers. So the next 14 minutes are yours to practice. I'm going to walk around and just make sure you guys are on the right track. You should be able to knock out those first 2 pretty quickly.